Okay, now the graph of sine in radians. Sine always starts at the origin and goes up to 1, back to 0, down to -1, back to 0. But this time, 90 degrees, we understand that as pi over 2. Pi is 180, so that's when we're back to the midline. 3 pi over 2 is our 270 degrees, so that's down at the bottom. And then we're back to the midline at 2 pi, which is what 360 degrees is. But now we need to think in terms of radians instead of degree measured. So that's one cycle. And then I just want to draw the continuation, but have one cycle nicely highlighted in red. Okay, the amplitude. I showed you yesterday, or told you yesterday, that the amplitude is the distance from the midline to the maximum, as well as the distance from the midline to the minimum. That distance in a parent graph of sine is 1. Amplitude is always positive. The period is telling you the amount of angle measurements you need to go through a cycle. That used to be 360 degrees. Now it's 2 pi radians. That's the period of the parent graph. If you horizontally compress or stretch the graph, that will change the period. If you vertically stretch or compress the graph, that will change the amplitude. Cosine. Cosine starts at its highest point, and then the midline, lowest point, midline, highest point, but now we need to get used to it in terms of radian measure. So again, I want to say pi over 2 is 90 degrees, pi is 180, 3 pi over 2 is 270, and 2 pi is 360. And just like sine, the amplitude of the parent graph is 1. The period of the parent graph is 2 pi. And we are going to look at sketching some samples. So here's example 1. I want you to notice that we don't have any multiplication division. We have an addition of pi over 2 directly to the x, and we have an addition of 1 outside of that function. So that means we're just going to take the parent graph of sine, and we are going to move it left pi over 2 and up 1. So what I'm going to do is I'm going to put in the points, the parent graph points of sine, and then I'm going to move those. So first of all, the origin, I move it left pi over 2 up 1, left pi over 2 up 1, and I'm just going to keep doing that. That gives me one cycle of the graph. This is now asking for 2 cycles of the graph. So starting at the midline, we again are going to go to the highest, the midline, the lowest, back to the midline. The amplitude, without any multiplication, the amplitude is going to be 1 and the period is going to be 2 pi, and I just accidentally pushed a button on my computer. There we go. Here comes example number 11, or second example of the day today. Now this time we have some multiplication and division. I'm going to start with plotting a few points of the parent cosine function. The parent cosine function is, it starts at its highest point. At pi over 2, it's at the midline. At pi, it's at the lowest. 3 pi over 2 back to midline, and 2 pi back to its highest point. And I'm just going to draw the one cycle and focus on that one cycle. The -3 is multiplying outside the function. That's going to take the y values of 1, -1, and 0, and all the y values in between, multiply every one of them by a -3. My positive 1 y value is now -3. My -1 y value is now going to be +3. And my 0 y values multiplied by -3 are still 0. So that's going to vertically stretch the graph and flip it upside down. But that's only looking at multiplying by -3 and not dealing with the other multiplication issue yet. So I'm going to draw this. And I'm going to erase the parent graph. And now we're going to take a look at inside the function with the x, I have division by 2. Whatever operation you see going on with the x, you want to do the opposite operation to the parent's x values. You see division, that means you are going to multiply all of your x values by 2. Now, my x coordinate of 0 multiplied by 2 is still 0. My x coordinate of pi over 2 multiplied by 2 is going to take me over 2 pi. So the first quarter section is being stretched out. Then where I previously, for my parent graph, had pi, I'm going to double pi. This is where the point is at. That goes over to 2 pi. And so my new point, this gets stretched over to 2 pi. And now we can see the first half of that green graph being stretched. Then 3 pi over 2 multiplied by 2 gives me 3 pi. So this point is stretched out to here. And then 2 pi multiplied by 2 takes me out to 4 pi. So this point gets stretched all the way out to here. And this would be one cycle of my new graph. You're being asked to graph 2 cycles. Once you have one, you just need to repeat the pattern. So repeating the pattern, you should see that this is what you are getting. Now, you're being asked for the amplitude and the period. The amplitude is the distance from the midline to the highest point, as well as the distance from the midline to the lowest point, It's always a positive number. So it's not -3, it is +3. The period of the graph looks at how long it takes to go through a cycle. So my final graph went through an entire cycle from 0 to 4 pi. That means the period is 4 pi. A way that you can find this without looking at the graph is to remember that if a normal cycle ends at 2 pi, and I have to multiply by 2 to find out where that end of my cycle has been stretched to, then I'm going to take my normal cycle length and I'm going to multiply it by that 2. Now, officially, the formula is that you have cosine of b times x. For this problem, our b is equal to 1/2. If b is multiplying by x, that's going to take a normal cycle length. So this is a formula to find the period of cosine of some b times x. You will take 2 pi and you will divide it by b. Whatever x is multiplied by, you divide it by. But you can also go through the logic that I showed you just a bit ago. But if b is 1/2, I just want to point out, with b being 1/2, then I have 2 pi divided by 1/2, which means 2 pi times reciprocal. All right, that is the end of that example. Now, the next thing we're going to do is we're going to come up with equations where we already see the graph. And these prompts, if I can get my pen to work again, these prompts are meant to help you to get going with finding that equation. This one is just asking you to determine the midline and the amplitude. That's it. That's the whole example. So let's zoom in on this graph a little bit. You might be able to see the midline. For some of you, you can see it. If you can't see it, you want to look at what is the y's highest value. My highest y value is 3. My lowest y value is -7. The midline has to be halfway in between them. How do I find halfway between two numbers? I can find halfway between two numbers if I find their average. I find average by adding them together and dividing by 2. So this is saying that -2 as a y value is where our midline is at. Some of you were able to see that without doing this arithmetic. I'm going to draw the midline in so you can see how it is very symmetric over that line. And for the midline, you're going to write that it is y equals -2. The amplitude is the distance from the midline to the highest point. and it is the same as the distance from the midline to the lowest point. And what is that distance? Five. Another way that you can find what that distance is, it's half of the distance between the high and the low point. So if you find the actual distance between the high and the low point, and then you divide by 2, that will give you your amplitude. And then I want to point out to you that if you're going to find distance between a high and a low, you are subtracting them. So 3 minus -7 is going to give me my vertical distance. But I want you to see that these formulas are very, very similar to each other. One of them is finding the middle point. The other is finding the distance from the middle point to the high and the low. All right. Now, the other thing is, can you figure out the period and the horizontal shift? The example we just did focused on the y values. When I'm looking at the horizontal shift in the period, I'm looking at the x values. And what I'm trying to do is figure out where is a full cycle. When I needed to do y values, that was easier. I could just look at where is the highest, where is the lowest. But when I'm trying to figure out my horizontal shift and period, I actually need to find where does a cycle begin and where does a cycle end. If I'm dealing with a cosine graph begins a cycle at its highest point. This could be a beginning of a cycle. Having trouble. Come on. There we go. So let's take a look at what number that is at. That's at half of pi over 4. So I am beginning a cycle of cosine at pi over 8. That's actually telling me my horizontal shift. And the horizontal shift is pi over 8, or maybe you want to say right pi over 8, but that is my horizontal shift. Now, can you see that to go through the full cycle, we have to go down to the bottom and all the way back up to the top, and then one cycle is done and it repeats itself after that. I need to know the x coordinate where that cycle ends. There are different ways that you can choose to go about finding the period of the graph, because all you need to know is what is this distance? What is this distance? Does anyone see an easy way to do this? because the harder way would be to look at what is the actual x-coordinate of this point, and then you've got to figure out what's halfway from pi to 5 pi over 4. But I don't need to know the x-coordinate of this point. I just need to know this distance. Does anyone see a smart move that will make this way easier to figure out? Having this start at pi over 8 makes this more difficult to see. If I decided that I would take this beginning coordinate and look at what happens if I move it over to 0, where would its final point move if I move everybody that much? So if I move the beginning point, and you're looking at a graph, so you can, if you want, count. That's 1, 2 of those lines, of those vertical lines. So I'm going to move this 1, 2. Here to here is exactly the same distance as here to here. What is that distance? Does everyone see that distance as pi? Yeah, I'm getting no response in chat. I'm hoping you're following along with me. The harder way to find the period of the graph, if you don't take that and just kind of shift the two ends to see a little bit better, you're going to have to actually calculate both of these x coordinates and then subtract them. Do you see that that's going to be really tricky though? I have to find what is exactly between pi and 5 pi over 4. That's not the best fraction fun. My advice is don't do it the hard way. Do it the easy way. When you see a graph, shift it back to 0 and shift the beginning of a cycle back to 0. Force the end of the cycle to shift back as well. And then you can see exactly what the cycle is, because it is whatever that final point shifted to. And that's a lot easier to do. All right. Now, where... Okay. Now, my next question is, can you come up with equations for these two? I'm going to erase some of this excess and leave just the answers of midline amplitude and horizontal shift and period. If you look at the homework, just to point this out, in the homework assignment, you're only going to be asked to go as far as what's the midline and amplitude, and then what's the horizontal shift in the period. What I want to do is prep you for what's coming, and that's to actually write the full equation out. So writing the full equation out, here we go. This is, if I look at this as a sine function, the amplitude is multiplied to that sine function. The midline is what I add or subtract to that function. However, this is only dealing with the vertical aspect. I still need to take a look at the horizontal aspect. And so what I didn't have you do with this problem, we're going to now do. Here is the midline location of -2 at my beginning radian angle of 0. I want to look at how long it takes me to go through the sine cycle. It takes me pi radians to go through one cycle. That means that I need to multiply my x by some number or divide x by some number. I also want to point out to you that because we were able to start the sine cycle at 0, we do not have a horizontal shift. There are only four numbers to keep an eye out for. 2 of them are multiplication or division. 2 of them are addition or subtraction. Of the multiplication and division, 1 is outside, 1 is inside. Of the addition subtraction, 1 is outside, 1 is inside. And I'm going to be careful to not give you too many of them at once. Does anyone think they know what that number b should be to make it so that the period of the graph is only a pi? Anyone think they know? You got it. And here's what you can do to help think about it. Normally, my cycle of sine starts at 0 and goes all the way out to 2 pi. So you could ask yourself, what do I need to do to 2 pi to take it back to pi? Now there's a 2 involved, but in what way? What do I need to do to a 2 pi to turn it into a pi? I need to divide by 2. Now, the inside operations are always tricky because they're the opposite. They're always the opposite operation of what you see going on. So there's multiple ways you can go about combating this problem. One of them is to think about, did I compress or did I stretch horizontally? If I compressed, hold on a second. I just realized that my mind is all over the place and I'm trying to bring it back. If I see division by 2, I actually needed to have a multiply by 2. So if you see that it compresses and gets smaller, you actually want to see multiplication. But if it stretches to get longer, you actually want to see division, which is awkward. So that's one way you can go about it. Another way you can go about it is the formula for finding the period of a graph is equal to 2 pi divided by b, where this is your b. If the period of the graph is pi, then what does b have to be? Haha. Does everyone see that b needs to be 2 in order to make that equation true? So know that you can always set up this equation of whatever you get for the period of your graph, it's equal to 2 pi divided by b. When I was mentioning that you have to divide your normal cycle by 2, that means you see the opposite operation of divide. You see multiply by 2 in the equation. So again, what you see with the graph horizontally, the equation shows the opposite operation. And this would be the equation. Now, let's turn to this one. If I use a cosine function, everything about the horizontal shift in the period needs to occur inside that function where the x would be. But listen really carefully to how to set this up. You want to set this up so that inside of that parentheses, you have b times x minus the horizontal shift with a parentheses around x minus horizontal shift. That horizontal shift was pi over 8, so x minus pi over 8 in a parentheses. And then if I know that my period is pi and I want to find b, we actually just saw that, but let's look at it again. Whatever I'm getting for the period of my graph, it will be equal to 2 pi divided by b. The period of my graph is pi. When I solve this equation, the answer is that b is equal to 2. Now, that takes care of the horizontal issue. But I still haven't dealt with the vertical issues. So now with the vertical issues, I'm going to erase some of this. When I'm focused on the vertical issues, I am looking at, I might be multiplying my cosine function by a number and then adding a number. Those are my two outside issues. Right now I'm putting a theta for everything inside so that I don't work with the horizontal at the same time as I work with the vertical. This is where I want to look at what is my highest and lowest y value. When my highest and lowest y values are the same but opposite signed, that means my midline is the x-axis. That means that I do not have a vertical shift. And so D is 0, so I don't need to actually write anything down for that. My amplitude is 3, but that means that the number I multiply cosine by is either a positive 3 or a negative 3. In order to know which one it is, I need to look at, based on this horizontal shift, this is saying look at starting to the right of 0, pi over 8. This is where I'm starting. If I start my cosine cycle at a high point, then that's going to be a positive 3. But I could have decided to make my horizontal shift, and this is the tricky part with the trig functions. I could have chosen to make a horizontal shift left but then I would have started at a low point, and that would have meant a negative 3. But because I chose to have this shift to the right of pi over 8 amount, and that caused me to begin at a high point, this is a positive 3. Now, you're not doing all that I'm showing you right now in your homework tonight. And I'm never going to give you a problem where you have to find this much out of one graph. This is a lot for one problem. But by looking at this right now, that's going to prep us for what's coming next when you do have to come up with the equations. What I'm going to do now, I'm going to stop the recording